instead of just in the past telling you that the vector went like this way, we draw it and say, hey, this is our vector M. Now we're going to say them with numbers always. And this one, I was already hinting that we could like think of that as over 3 and let's say up 2, and then we could call it 3, 2. This is the day where they officially show you the math behind how that can be done. But then you also have to get used to these vectors can be said as 3i plus 2j. And weirdly, this isn't the x-axis anymore, it's the y-axis. And I just drew my j backwards, which is messing with my head. There. And j is this axis. Remember, we're not in rectangular right now. Vectors are a whole different thing. And so it's not the x and the y axis, it's the I and the j axis. All right? So, if I said I had this vector, M, and before I would tell you like, okay, now we're going to add this other vector, I'm going to make a little blue vector, and I'm going to move it so that it's right there. This little blue vector has a name too. And its name is, it went over 0 spaces as it moved. It went over 0, and it went up 2 spaces, 0, 2. And let's call that vector R. The R vector. And I already taught you how to add them, and so then you'd be able to say, oh yeah, I know this. The resultant is this, the green arrow. And that goes over 3 and up 4. So this green resultant arrow is 3. I always want to make a fraction bar there. 3, 4. I'm going to move the 3, 2 to right underneath the red one and make it red so it's a little more. So 3, 2 plus 0, 2 does make 3, 4. And if you just write the vectors in alone without the distraction of the picture, it's super simple. Doesn't it seem obvious that 3, 2 plus 0, 2 makes 3, 4? I don't always want to put a fraction bar. I want to squeeze a little plus in there. That 2 got too sloppy. Come on. That hopefully seems really obvious. You just add the top number, add the bottom number, and they all add up, and it's no big deal. All right, so where do I want to get today? I also want today be able to say 3i plus 2j. Now I'll make a different color for this one. Plus 0i, and you'd want to say 0i, even though I know 0 times anything is 0, but you'd want to say that to make sure that people see that you know there's an I component, plus 2j is equal to what? So that's like this one, and this is another way to say that one. Did you notice the title of the notes for today? Like in Schoology? What did it say? Vector representation. Okay, but there was another pausing for a second. So there you found it. The position versus column are the two keywords there. The blue ones there, those are column vectors. Those are column vectors because they're in a column. These are called position vectors. Okay, so when you write it like this, you're giving a position vector. And that, of course, goes with this guy here, but that's in a column. It's a lot cleaner to use columns. Just two numbers. It's pretty easy. So I think you'll probably, usually, if you're given a choice, you probably like to write them in columns. But I'm telling you, there's problems coming where you've got to write equations for them. Do you get that these guys kind of look more like equations? And solving a system of equations ends up being the answer to a lot of these questions at the end. So we need you to know how to do the position vectors, this new one I'm just showing you today here. We need you to know how to do that because you're going to be writing two equations and then solving the system. I'm going to take a second and just sidebar and talk about that because it's so important in algebra. If I said x plus y, imagine that could be like I plus j. In fact, let's do that. Let's make it I plus j. Let's say everybody had 2i plus 3j. And does that look like an equation so far? Well, an equation has to have an equals at the end, right? Let's say that I said equals 4i plus I don't know what, so I'm going to call it nj. Now, can you just look at this? You know, I don't like the way this is going. I'm going to stop because I should wait until we actually do this on that day. I think doing it ahead of time with column and position vectors is a bad idea. But what I can tell you, you have to know coming in, and I think you'll all be good with, is just plain old-fashioned equations. If I said 2x plus 3y equals 12, and I said 6x plus 3y equals 36, would you be able to solve that? Okay, write these two, act like it's the ACT test. Whether or not you get this, get you a point on the ACT. Should typically be able to be done in one, maybe it's a little harder than average, so maybe 1.5 minutes is how much time you should allocate. Let's see if you can do it. I'll give you a hint. You could do substitution, where you solve for one variable and stick it in the other, but it'd be so much faster to use elimination, where you draw a line across here, and you do something to make one of the variables eliminate itself. Let's see if you can do that. If you don't remember, I'll show you in about a minute.
You could just subtract 2x from each side.
Okay, so let's subtract 2x from both sides. Minus 2x minus 2x. And then I'd have 3y equals 12 minus 2x, or I'm going to say minus 2x plus 12. Then I divide everything by 3. And it's a bit of a pain to solve that far even. And then that's 4, right? But now you got y equals. And then you could go plug that in where?
Second.
All right. Would you agree this is a pain?
Yep.
Okay. Let me show you the much easier way. Who knows the other way that I'm about to show them? Tyler.
You can subtract one equation from the other.
Yeah. Watch how fast this is, guys. I'm going to subtract, subtract, subtract. Look at those two, all primed to cancel each other out. That's called elimination. They are eliminated. And I'm subtracting here, right? I did the opposite of each of those things on the bottom. You can do that, can't you? Can't you multiply through by a negative on the bottom? Sure you can. You get negative 4x is equal to negative, and then what does that make? Negative 24, I believe, right? Okay. And then isn't this super easy? Divide both sides by negative 4. Isn't it 6 times 4 is 24? So it'll be 6. So x is 6. And if x is 6, then you can go back into this original equation, which was a really easy equation, and put a 6 in where x is. And you can say 2 times 6 plus 3y had to equal 12. Well, 2 times 6 is 12 all by itself. So then y must be 0. Y must be 0. The answer was 6 comma 0. That's called solving a system of equations with elimination. How many of you did it that way? All right. The rest of you, now that you saw it, hopefully you could do it. Everybody try this. 2x minus 5y equals 10. And 4x minus 6y is equal to 12. But Mr. Server, you can't just make the bottom negative. Nothing cancels out. You're right. So, you multiply not just by a negative across the bottom, but you could multiply the top one by something strategic. Who sees what we could multiply the top one by that would make this work really nice? Opal.
Just multiply by 2.
All right. How about -2 right off the bat? I know what you were going to say. You're going to multiply by 2 and then you were going to like make it subtract. But what if I multiply by -2 right off the bat?
Yeah.
I'll just save a step. Get how that's -4, which is going to cancel +4, and then they're canceled and gone? That's going to make positive 10y. Put it with the -6, and I get 4y. -20 and 12, -8. Y equals -2. Boom. And from there, I hope it'd be easy for you to stick it back in and solve for x. See what happened there? All right, you all need to be good at algebra because you're in pre-calc. In fact, you're in honors pre-calc. So I just needed to take a second to make sure you got good at that. It's not going to be like a huge deal today, but it's coming. You're going to have a system of equations like this, except it's going to have i's and j's in it. Do you get that wouldn't work so well if it was like 4, 0 for your equation? That doesn't look like an equation at all. But I just told you how to make that an equation. Would you please? Make that an equation. Technically, you're making it an expression because we don't know what it equals. But if you knew what I was talking about, it's 4i plus 0j. Raise your hand if you had that one right. Okay, cool. You're on track. This is called a column vector. This is called a position vector. Now we got to go into 3D. What do you think 4, 0, 5 means? Well, if you're going to picture where this thing is, this is like the x, this is like the y, and this is like the z? Yes. And that's why I have this thing hanging in the room. For those that are watching the video, you can't see this, but I have a 3D axes with string, basically, going across the middle of the room. So I have an x-axis, which is the green one, is the x-axis. Okay. The y-axis is going up and down, as you would expect, comes from the ceiling. And the z-axis comes out towards you or goes away from you. I'm surprised at how many people's gut feeling is wrong on which way positive and negative is. Well, you all know what the x-axis does. As you move to the right, your right, it's positive. Okay? And as you move up, that's positive. But which way do you think is positive when it comes to the z-axis, the one that comes out towards you and goes away from you? I'm going to say Henry this time.
Positive going away from
All right. Do you agree with him or not? It's going to be half and half. All right. So who feels that positive should be going away from you? And who feels like positive should be going towards you? And obviously a lot of you didn't vote, but that was about 4 to 3. See what I mean? Like people just don't know. Had somebody look it up last time we had this debate. Coming towards you is positive. I know. It's kind of freaky. Doesn't feel right to you, does it? All right. So go ahead and Google it if you want to. I get it. You might think I'm wrong. I get it. And maybe the kid was wrong. That could be possible, and I'm teaching the whole class wrong. So go ahead, check it out. Act like you know. Which way does the z-axis go? And I bet you'll find it. And if anybody can either verify it or refute it, let me know. All right. Did you look it up? Oh, go ahead and look it up. Yes.
I looked it up.
Read me exactly what it says.
I can't find it.
What did you think it said?
It said, z-axis is negative coming towards you.
Oh my gosh, now I've got two different,
Or I mean negative going away.
okay,
Negative.
okay. Negative going away from you would be the same as positive going towards you. So positive going towards you. All right. Maybe if you remember it this way, if I put like a whole bunch of money out on the table and it was you and all your brothers and sisters, what would your first instinct be? Grab it and pull it towards you. That would be positive for you, right? My brother did that one time. It was one of his favorite things. Somebody had passed away and in his family and given him a few $1,000. And he was like, you know what? I'm gonna share it with my kids. And so he went to the bank and he got it all in ones. So he had a few $1,000s and he took it and he had a paper bag and he dumped it on the kitchen table. And he said, look guys, this is for you. It was just like hundreds and thousands of dollars in ones. And they were just like pulling them towards each other. And anyway, it wasn't just like who got the most, like got to keep that. It just divided it all up and they got to feel what that much cash felt like. So, anyway, if you want to feel what that much cash looks like, my daughter was able to make over $2,000 watching other people's pets over the summer. So, if you want to feel like a couple grand feels like in your hand, go watch people's pets. It's amazing what they'll pay you to watch their pets. Even people that just feel guilty that their dog really could use a walk and they're too busy, they'll pay you good money to walk their dog. And they'll let you do it like day after day after day because the dog wants a walk every day. So anyway, if you want to feel hundreds of dollars in your hand, that's a way. All right, so next, if I wanted to take any of my X, Y, and Z points and draw them, it is very challenging to draw on a two-dimensional surface, right? If I want to go to where 4, 0 is, that's easy. Over 4, up 0 means right there. But now you have to imagine it coming back towards you, 5. Okay, and some people are good at this 3D visualization and some people aren't. Would you, in the room right this second, would you please try to visualize where 4, 0, 5 is? Where should it be in the room? There's only one right answer. Where should 4, 0, 5 be? Don't say it. Think it. I had a lacrosse ball in here. There's one class. So I was just showing them that in the room where 2 points might be. If we had 2 points in plain old 2D space, we've got a way to do that. If I had this point, which appears to me to be 2, 3, and I had this point, which appears to me to be 8, 5, you could write an equation of the line that goes between them, but you'd need the slope, right? Let's just see if you remember this. Here's 2 points. Find the equation of the line that goes between them. Hint, find the slope first. Then, try to figure out how you would set that up. Because finding the equation of the vector from one spot to another is the same basic process. Lainey, how do I figure out the slope again? Remind me how that works.
You do y2 minus y1 over
Okay.
x2 minus x.
So that'd be like 5 minus 3, am I starting right?
Yeah.
Over 8 minus 2. 5 minus 3 is 2. 8 minus 2 is 6. 2, 6 reduces to 1/3. It's like a rise of 1 and a run of 3. Does that ring a bell? Okay. Then we had this other equation. Well, we don't have a nifty equation like this for vectors, but do you remember this equation? Y minus y1 equals m times x minus x1. If you haven't already, why don't you use the 2, 3 point, please? and put that and the slope into the equation, and you'll have an equation for that line. Well, the y of it is 3, so it's y minus 3 equals the slope we just figured out is 1/3. X minus the x of it is 2. And there's my equation. We got an equation for a line that goes through 2 points. How are vectors different? Well, they're a lot different. They start at one spot and they end at the other. They don't just keep going forever because they have a length. Nobody ever asked you, what's the length of this line? That wouldn't make any sense. Okay, so they're definitely different, but they're similar because we can describe these vectors in 3D space as a point. And instead of 2, 3, we could have said a point in 3D space could have been 2, 3, 0. I mean, you can do 2D in 3D. And do you get this 8, 5? What would that have been? 8, 5, what? 0. The y distance just doesn't move. Okay. And you could have got a slope between those two, couldn't you? All right. I feel like you're ready now, with all the review that's important, to go into the notes. So if I asked you to add up OC, which is supposed to be a vector, and OD, which is supposed to be a vector, here's OC and OD. Can I add them that way, tail to tail? No, it's a leading question. Obviously, you have to move that over, and now I did tip to head tail, and now I go, ooh, that's the resultant. This ringing a bell? Okay. So they're just saying here that you can write it as column vectors or position vectors. And they just say A equals, if they want it to be vector A, they just say A equals that. They don't have a number that it equals. They just give it a letter like the vector Q or whatever. Okay? All right. So this is just trying to describe that 3D space and yet doing it on a piece of paper. So I think I've tried to do that in the room where we have 3D, so. Now we'll go here. This is important. If I say the vector looks like this, you should be able to tell me in column vector form, what is it? You might be like, but it'd be easier if it was over here. Yeah, go ahead. In your head, move it over there. Or you can just say, how far over does it go? How far up does it go? And write this vector in both ways. We're not going to add them or subtract them, any of that stuff yet. Just write them in both ways. If you said 4, 3, raise your hand. Good. Then you get what's going on. What's the other way to write this? Alec, what's the other way to write it besides 4, 3? I'll come back to you in a sec. Jacob.
4I minus 3j.
Minus 3j.
Plus.
Okay, plus 3j. I thought we went up. If you had said minus, we mean we would go down instead of up. Okay. All right, good. So there's the two different ways you can represent the A vector. The other way is to just draw it, which is what they did. Okay? And then they're just going to add the vectors again, and we've already talked about this. You just have to add the numbers, so it's super easy. Subtracting, again, the only thing that might have been an eye-opener for you is that it's not like both of them become negative. Look, A is exactly the same. The B vector has to go the other direction when you are subtracting it. So let's get the B vector now. By now, somebody's got this. Notice the arrow tip. Notice it was going this way and this way. Okay. So did you have B as negative 1, 2, 3, 4, 5? And then it goes up 1, 2, 3, 4, 5. Did you guys get negative 5, 5? Okay, cool. Now usually I don't use these until I have to. I don't use position vectors very much. I use column vectors because they're so much easier. So now if I said, what's a plus b, it would just be 4, 3 plus negative 5, 5. And it's as easy as you would think. 4 plus negative 5 is negative 1, and 3 plus 5 is 8. That makes sense to you? But if you don't do the opposite of both of them. If you're going to subtract, you do negative on this vector, and everybody write down what you think you should get. Did you get 9, negative 2? Okay. I want you to get what the picture would be. If I added a and b, a plus b went kind of like that. A minus b, the b vector just goes the opposite direction. So all of a sudden that's a and that's b. The b vector goes the opposite direction. So you end up way to the right and down. See, from here, look, it's going to the right and down, which will make sense. Okay, and then the last part is, how do you put a 2 in front of a? Well, it's really easy. You put a 2 in front of a. You put a 2 there. What's your gut feeling on what the 2 is going to do? Doubles them both. So it's 8 and 6. And then half of the b, well, then it's going to cut them both in half. Half of this, half of that. Those are kind of a pain. Half of 5 is 2.5. So, okay, I think you get the idea there. So, you've made it. And here's a typical problem. What the heck does 3b mean? I encourage you to use the column vectors unless they say otherwise. So let's make a column vector for b. 4, 7, 5. There. That's your b vector. And I'm supposed to do 3 times that. So 3, 4, 7, 5. So what's that? It's a new vector, and it's a lot bigger. It's 12, 21, 15. Make sense to you? All right. Now, instead of hoping that you're going to do some homework, this is the part where I'm going to assign you a Schoology quiz to start immediately and finish at home. Then I'll know whether you did it or not. Okay, so there's a Schoology quiz in there. I said in the on the title of it, wait until I assign this in class. I just assigned it in class. All right, so I get you're not going to finish it in class, but get started, please, right now on the Schoology quiz. And this will really help set this into your memory. I told you, I think, that this is the hard test that's left. We get through this one test, then we have an easy test after it, and then the final only counts for like half a normal test, about, and that's pretty nice. And it's all problems you've already done on previous tests. Okay, not the exact problems, but very similar. Okay, so just have to remember past stuff. Nothing new on the final. It won't go all the way to the beginning of the year either. It's just the last half of the year, second semester. All right, that's all I got for the video for today.